Okay, what if I told you there's a cosmic object out there so extreme it could actually go head to head with a black hole? Well, today we're going to dive into this really strange theoretical rival that could totally change how we see the entire universe. Yeah, that's the core idea right there. The universe, it seems, might have something even weirder than a black hole up its sleeve. We're talking about an object, the theoretical one for now, called a gravastar. All right, so let's set the stage. In one corner, you've got the reigning, undefeated champion of cosmic heavyweights, the black hole. We all know it. But in the other corner, we have this mysterious new challenger. And to really get a handle on this contender, we first have to understand the fight itself. So, you know how it goes. When a really, really massive star dies, it goes out with a bang, a supernova, and its core gets crushed by its own gravity. Now, this usually leads to one of two things. Either it becomes a super dense neutron star, or it just keeps collapsing, basically breaking reality and forming a black hole. But what if there's a third option? Something even stranger. And this is exactly where gravastars come into play. See, the theory describes them not as these points of infinite density, like a singularity. No, it's something more like a giant cosmic soap bubble, filled to the brim with pure energy and wrapped in a shell made of the most extreme matter you can possibly imagine. So, how in the world is one of these things born? Okay, picture this. As the star's core collapses, instead of forming that physics-breaking singularity, it gets pulverized into pure energy. This creates a bubble, and this bubble then expands, just violently, slamming into all the other matter from the star that's still falling in around it. And that quote just nails it, doesn't it? It's the perfect illustration of that moment of creation. You've got the outward push of this energy bubble meeting the inward crush of all that gravity. It's this incredible cosmic clash that forges all that infalling matter into a totally unique, ultra-strong shell. And just like that, a gravastar is born. Okay, to really get a sense of just how wild these things are, let's just break down the scale, okay? A typical gravastar would be shockingly small. We're talking roughly the size of a city like London. But get this, crammed into that tiny space is an unbelievable amount of mass, like as much as 10 of our suns combined. And to top it all off, its surface would be the coldest place in the entire universe, just a billionth of a degree above absolute zero. So just try to wrap your head around that. It's the size of a city, weighs as much as 10 suns, and is colder than literally anything else that exists.
Wow.
So you gotta be asking, how can it possibly be that cold? Well, it's because this shell isn't made of atoms like you and me. Nope. It's some kind of exotic material forged at the absolute edge of what physics allows. And it's so incredibly thin, yet so ridiculously tight, that you would need the energy of an entire supernova just to stretch it by one single meter. No way. Okay, so what's inside this crazy shell then? Believe it or not, it gets even weirder. It's a perfect vacuum, completely empty space. But, and this is a huge but, this isn't just any old nothingness. This is a nothingness that is literally boiling with a kind of primitive, fundamental energy. To get our heads around this, let's try an analogy. Think of the vacuum of space as this fundamental ocean that's just everywhere. All the particles that make up you, me, the stars, everything we see, they're just waves on this ocean. But even when there are no waves, when it's perfectly calm, the ocean itself is still there, right? And it has its own built-in energy. So here's the kicker. The way a gravastar forms, it compresses that vacuum ocean down to its absolute physical limit. This creates what you could call super dense nothingness. And this stuff contains an almost unbelievable amount of energy. And it's that energy that generates the insane gravity, making a gravastar look and act almost exactly like a black hole from the outside. Okay, I know what you're probably thinking right about now. This is a super weird, mind-bending idea, but what's the point? Why would physicists even bother coming up with a concept as absolutely wild as a gravastar? Well, the answer is pretty simple, actually. Gravastars were originally proposed to solve some of the most profound and, frankly, frustrating puzzles that black holes throw at our understanding of the universe. Yeah, for all their cool factor, black holes give physicists two massive headaches. First up, you have the singularity, that point of infinite density where our laws of physics just completely break down. They just stop working. And second, they seem to delete information. Things fall in and the information about them is just gone.
which, according to everything else we know about the universe, should be totally impossible.
And this is where gravastars come in as this really elegant solution. They neatly sidestep both problems. See, they have all that immense mass and gravity, but they don't need a singularity at their core. So, there's no breakdown of physics, and information isn't deleted, it's just converted into that vacuum energy inside the shell. It's a potential solution that keeps all the laws of physics happy and intact. So, okay, we have this really compelling alternative theory, but how could we ever know if they're actually real? I mean, is there a way to tell a gravastar apart from a black hole? Well, it turns out there just might be a way to listen for the difference.
The key difference. It all comes down to the edge. A black hole has an event horizon, right? That's a point of no return. A gravastar, on the other hand, has a hard physical surface, that shell. And this one fundamental difference means they should behave very, very differently when they smash into each other.
Okay, so when two of these absolute monsters collide, they send out gravitational waves, these ripples in space-time itself. You can kind of think of it as the music of the cosmos. And here's the test. A collision of two black holes should sound like a deep bass drum, just a thump that stops pretty quick. But two gravastars colliding, that should sound more like a giant gong, with the vibrating shells leaving behind these subtle little echoes in the signal. Now, the challenge here is just immense. Scientists are out there, they are listening for these echoes, but the intense gravity from these things basically swamps most of the signal. It's kind of like trying to hear a faint whisper through a super thick concrete wall. For now, our tech just isn't quite sensitive enough to pick it out. And really, that's where we are right now. The verdict is still out. Gravastars have the potential to completely revolutionize how we understand gravity in the universe. Or they could end up in the discard pile as another one of those fascinating but ultimately incorrect ideas. But hey, this is exactly how science works, right? You question things, you propose wild alternatives, and then you hunt for the evidence. Because whether it's the thump of a black hole or the lingering echo of a gravastar, listening to these cosmic collisions is a whole new way of seeing the universe. It really makes you wonder, as our instruments get more and more sensitive, what other incredible secrets are just waiting for us out there, hidden in the music of the cosmos?